In this video, we will be changing a quadratic equation from standard form into vertex form using completing the square. 2 out of the 3 methods shown will be using completing the square. Our key step for completing the square is we multiply 1/2 times the coefficient of the linear term, the term that has just the x, and we square that value. The reason why this is the key step is we're trying to force a quadratic equation to be something we can factor. So let's look at a generic example, hopefully to give you a better picture of what's going on. So x minus 3, when that's squared, we can expand it out into x minus 3 times x minus 3. Multiplying these binomials together, we end up with x squared minus 3x plus 9, and combining our like terms, this is x squared minus 6x plus 9. This is called a perfect square trinomial because we can factor it into something, just a binomial square. So if we took 1/2 times b, half of a -6 gives us -3, and we square this value, a -3 times a -3 gives us 9. That is a perfect square trinomial. So this is our key step that we're going to use every time we are completing the square. So here's our first example. F of x is equal to x squared minus 8x plus 15. We want to change this into vertex form, something where we can clearly read the vertex off, h and k. Method number 1, we push everything to the left-hand side. So our opposite of adding 15 on both sides, we subtract 15 on both sides, and then we take our key step. Our coefficient, our linear term, we multiply that by 1/2. So half of a -8 gives us -4. We square that value, -4 squared gives us 16. We add our result to both sides of our equation. So we're keeping our equation balanced by doing the same exact thing to both sides. Now what we can do here is we can factor. So what two numbers can we multiply together to get a positive 16? But when we add them together to get 16, we get -8. The shortcut is whatever we take half of the linear term to be, that's always what's going inside of our parentheses. Now, to get f of x by itself, our opposite of adding 1, we subtract 1 on both sides. So here is our vertex form of the equation, and our vertex is 4 and -1. Method number 2, we keep everything on the right-hand side. So here we just take that constant and push it over a little bit so we know not to touch that term. We do perform our key step, half of a -4, -8 gives us -4, -4 squared is 16. This time, since we're keeping everything on the right-hand side, if I add 16 in this step, I need to subtract it on the same side of the equation so that we're essentially adding 0. We're not changing the problem. On the left-hand side here is just a more visual way of seeing it. If we subtracted 16 on both sides, we have the same thing. So now we factor the first 3 terms only. We have x minus 4 squared, and then 15 minus 16 gives us -1. That's another way of completing the square. Method number 3 is the shortcut with the formula. So our formula for our axis of symmetry with quadratics is -b divided by 2a. To find our vertex, our x coordinate is the same as the x value from our axis of symmetry. And then we take that x value and plug it into our function. So our a is the coefficient of x squared, our b is the coefficient of x, our c is the constant in the problem. So once we evaluate our formula for both of these, then we have 8/2, which gives us 4. So we evaluate our function for 4 squared minus 8 times 4 plus 15, we have a value of -1. So our vertex, the x value is 4, the y value is -1. And when we substitute both of these values into our function, our h is 4, our k is 1. Remember, there's a minus sign in the formula, so we put in our x value behind it. And you end up with the same form of these other two. Let's look at another example where now our leading coefficient is not 1. So method number 1, remember we're pushing everything to the left-hand side. So the first thing we're going to do is to move our constant minus 6 to the other side, so f of x minus 6. Then we want to change this. We want to divide every term by our leading coefficient. So we're dividing everything on the left by negative 2. You're dividing negative 2x squared by negative 2. You're dividing 4 by negative 2. And now our leading coefficient is 1. Key step, multiply 1/2 by the coefficient of the linear term. We're going to square that value and add the results on both sides, keeping our equation balanced. Whatever we do to the left side, we have to do to the right side. Factor the right side. Remember, whatever half of this linear term is, that's what's going inside of our parentheses. And now we want to get f of x by itself. So the opposite of adding 1, we're going to subtract 1 on both sides. Our opposite of dividing by 2, we're going to multiply both of these terms by negative 2. And then to get f of x by itself, opposite of subtracting 6, we add 6 on both sides. So 2 plus 6 gives us 8. That's one way to do it. You're pushing everything to the left-hand side. Method number 2, we're keeping everything on the right. So we take our constant, we push it over a little bit to the right because we're not touching that term. And we want to factor out that leading coefficient from those first 2 terms. So if I factor out negative 2 from our first term, we have x squared left. Factoring out negative 2 from the second term, we have negative 2. Now our key step, inside the parentheses, whatever we take half of that middle term to be, that gives us negative 1. We square that value, and we put positive 1 here. So the tricky part about this problem, to keep our equation balanced, we cannot forget about what we factored out originally. We factored out negative 2. So what we really did was negative 2 times 1. We really subtracted 2 here. And if we're keeping everything on the right-hand side, if I subtract 2, I have to keep this equation balanced by doing the opposite, adding 2. Now we factor everything inside the parentheses, so that becomes x minus 1 squared plus 8. Once again, same answer. This step looks shorter, but you have to remember to redistribute that value in front. Third, method 3 is our shortcut with our formulas. Our equation for our axial symmetry is x is equal to a negative b divided by 2a. Our a value is the coefficient of x squared, negative 2. Our b value is the coefficient of x, 4. Our c value is the coefficient, the constant, 6. So plugging those values into our formula, we have a negative 4 divided by 2 times a negative 2. Always simplify that denominator first. Negative 4 divided by negative 4 gives us positive 1. That is our equation for our axial symmetry. X is equal to 1. Then we take that value, plug it back into our original formula. So negative 2 times 1 squared plus 4 times 1 plus 6. And there's our y-coordinate of the vertex, 8. And we plug this into our standard form. H is whatever the x-coordinate is from the axial symmetry. K is whatever the y-coordinate is. And you have to remember in front that this a value is the same a value from the very beginning. So you have to make sure to put that a value back into your equation.